Hello, and welcome to Inforce, everyone. Thank you for coming out today. I'm really happy to be here, and seeing everyone in person just makes it great. I'm Swara Gandhi. I'm a solutions architect with AWS Identity. And today I'm joined by Itai Kohai and Zulfi Heather from Morgan Stanley. Itai is an executive director of Cloud Platform Engineering at Morgan Stanley, and Zulfi is vice president of Cloud Platform Engineering at Morgan Stanley. So now, if you are maintaining multiple AWS accounts for your business and are looking to put a central control over those accounts, or if you're just looking to write a really effective service control policy, then you are in the right place. We are going to talk about everything that is service control policies. And we also have a major Wall Street bank, Morgan Stanley, with us today to share how they use SCPs in their production today at scale to strengthen their security controls. So let's go ahead and get started. So first we'll go over the basics of service control policies. We'll just see what they are, why do we implement them. We'll talk about how to write really effective service control policies. And then we'll talk about how to get most of your service control policies, how to get most out of them, how to write really effective and compact SCPs. Then we want everyone walking out of this session to have at least some service control policies in mind to either get started with or mature your usage. So we give you top 5 recommended SCPs. And then in the second half of the session, we have Morgan Stanley coming in and sharing with us their AWS organization and SCP evolution. What were the lessons learned while implementing them practically? And then what are the use cases in play today at Morgan Stanley? Okay, so today I see our customers using multiple AWS accounts. And as your workloads grow and as the number of accounts grow that you use for your business, you look for a control that you can put centrally that could be implemented and applied to all these accounts that you own. So SCP is one of that tool, really powerful, scalable tool given by AWS for you to control what your principals can do in your organization. Now, when you have multiple AWS accounts, there is a natural isolation between these accounts, meaning an entity in one account cannot access an entity in another account unless you explicitly grant that access. So here I'm just showing a basic AWS organization structure where you have a root at the top, 2 organizational units, and then you have 2 accounts in each organization unit. You can apply SCP at any level in your organization, and we'll discuss about this a little bit later in the slides. However, when we talk about SCPs, I want everyone to start thinking about the broader set of controls that you want to apply in your organization. The security invariants that should be true no matter what. And some controls that you want to implement across all the accounts that you own or a group of accounts in your organization. So it has a really big blast radius when you apply SCPs. Now I want to call out something over here, which is SCPs define the maximum allowable permissions, meaning SCP is a guardrail. SCPs do not give access. It is only a guardrail. However, there are 2 other kinds of policies which actually grant access, which is identity-based policy and resource-based policies. Now, identity-based policies are the policies that you attach to your IAM principles, and resource-based policies are the ones that you attach to your resources, which is S3 buckets, SNS queues. So with these grant permissions, identity-based policies and resource-based policies, you're actually saying, go create S3 buckets or go create SNS queues. You are giving that kind of access to your developers. But with SCP, it's an guardrail. You cannot grant access. You can just define the maximum allowable permissions. So if you have all these 3 in your organization implemented, then the effective permission is the intersection of all 3 of them. So if a particular action is allowed by all three of them, then that access would work. So let's look at an example over here. I have incorporated multiple examples in my slides. That is how I learn the best. So we are going to look at some of the policy snippets. So make sure you have your SCP glasses on. So SCPs only apply to your principles, meaning the IAM principles that are owned by your organization. Could be IAM roles, users. And here we are showing an AWS organization. Think of it as you own this. You have 2 accounts that you're getting started with, and both are part of an organizational unit. We only have one OU over here. Now you want any access that is made to your S3 buckets to only come in using TLS connection. This is a good policy to keep in mind, by the way. It didn't make it to our top 5 recommendations, but still a good one to keep in mind. So I was saying, deny any S3 action on any of my S3 resources if the secure transport layer is not used. So meaning if a request is coming in without using HTTPS connection, you are not allowing that request. So let's say you apply this at the organization unit level. Now, we have an IAM role that is created in account A, and we have a bucket with your objects in it in account B over there. And let's say the role in account A is trying to access the objects in account B. Just keeping in mind, I'm not showing a policy that is attached to your bucket or role over here, but let's just assume that they have permissions given. So the bucket has permission given to the role, and the role has given permission to the bucket. So in this case, what will happen? Keep in mind, we still have the SCP applied at the organization unit level. Because the role belongs to your organization, this kind of access would be denied. Because the account A is part of your OU, and OU has a SCP attached to it. And the role belongs to your organization, which is most important. Now let's look at a flip side of this, where you actually don't own the role. So now let's say we only have one account. It has a bucket with your objects in it, account B. We are still looking at the same SCP applied at the same OU level. And now, because we will be talking about the cross-account access, when you want to grant cross-account access, you need a policy on both the ends. So a policy in both the accounts, right? If there is an account outside of your organization trying to access your resource, you need a resource policy that allows that access. So we have a bucket policy over here, which is attached to your bucket. This is a resource policy, not an SCP, that allows a role C, which is coming in from an external account, to perform any S3 action on your workloads B bucket. Now on the bottom, we have an external account. This is an account that you do not own, which is not part of your organization. And we have a role C sitting over there, which is an external account. Now, because both the parties should agree for a cross-account access, we also need a policy attached to role C that allows it to access our workloads B bucket. So let's say we also have that policy attached to it. So we are good from the resource policy perspective, we are good from the identity-based policy perspective, but we still have an SCP applied at the organization unit level, which account B is part of. So now let's say role C tries to make a HTTP connection to your S3 bucket. What will happen in this case? This will be allowed. And the reason is in the title. SCPs only apply to your principal. So how do we get around this? If you want to implement a policy that denies this kind of access, you have to implement it at the resource policy level. So you can have a S3 bucket policy that denies anyone to perform any S3 actions on your workload's B bucket if the TLS connection is not used. But this will go in a resource policy, not an SCP, when you're dealing with principals that do not belong to your organization. So let's look at the diagram again. However, in this case, because role C is not part of your organization, SCP doesn't apply over here. The access completely relies on your identity-based policy and resource-based policy. Okay, so now that we know what service control policies are about, let's talk about how to use them effectively. So one question I always get from customers is, how do I know what goes in an SCP and what goes in a resource policy or other types of guardrail policies, right? So I want to talk about 3 guardrail policies over here: SCPs, permissions boundary, and session policies. All 3 of them are guardrail policies. They do not give access. They just define the maximum allowable permissions. However, 3 of them have different blast radius. 3 of them have different scope of impact. SCPs apply to all the accounts in your organization if you apply it at the root level, or they apply to a group of accounts if you apply it at an organization unit level. However, permissions boundary only applies to a particular principal. So if you only want to scope down permissions on one particular IAM role, think of using permissions boundary rather than using an SCP. That control goes in the permissions boundary. And lastly, session policies. Now this is the most granular you can go. Session policies are the policies, scope down policies actually, that you attach to a session. Say you assume a role to perform certain actions in your AWS account, and you can pass in a session policy on the fly. So these are for the decisions that you want to make on the fly, right? We see customers using this all the time. Let's say you have a general policy, but somebody needs only access to S3. So you can have a scope down policy, a session policy passed for that particular assumed role that only allows S3 and not everything. So based on how wide of a scope you're implementing a particular control on, you move from left to right. And also based on the scalability. So if you're higher up the chain in your hierarchy from the root, if you're thinking of applying a control at the root level that should be applicable to all the accounts and OUs, you apply it at the SCP level. However, if you're going more granular into principal and a session level, then you apply permissions boundary and session policies. So decide on how big of a scope you want, and then use these guardrails according to it. Okay, so we talked about what are SCPs and how to implement them, what controls should actually go into service control policy. Now let's say you have that ready, you have it in mind, and you actually sit down and you start writing SCPs for your organization. So I'm going to talk about how to write a really effective SCP. So we are going to discuss the techniques that you can use so that you can get most out of them. So the first technique is using inheritance. Now because you can apply service control policies at different levels in your organization, you can apply it at the root level, OU level, or account level, you can make use of inheritance. And we'll discuss about this a little bit later in the next slide. Next, you can combine policies together. And I have a really cool example for this. And you will need to combine policies together to stay within the maximum permissible amount of policies that you can apply at each level in your organization. And to stay within the maximum length of a particular policy, we'll look at how to compact a SCP. So first, let's look at inheritance. And there's something really important that I say on this slide, which is taking advantage of inheritance for deny. And I explicitly say deny over here because you can have either a allow policy or a deny policy, a SCP, in your organization. So if you have a deny, let's say, it will be inherited as it is down the chain. So if you apply a deny policy at the root level, it will be inherited by the OUs and the accounts created under it. However, if you have an allow policy attached at the root level, you still need a allow SCP at the organization unit level and on the accounts for it to work, because there is no implicit allow. So here, I'm just showing you can attach a SCP at the organization root level, at an OU level. Depending upon if you have like a DevOps OU and production OU, you can make it more strict on the production OU. And then you can also attach it at the account level. Keep in mind, if you are making use of allow policies, you will need it at each level. However, for deny, it will be inherited down the chain. So let's look at an example for this. So we make it more clear. We have the same organization structure over here, same to account A and account B. But however, in this case, we'll apply SCPs at different levels and we'll see what the resultant policy would be. So let's say you apply a policy at the root level. We have Morgan Stanley with us today, so I'll just give an example of a bank. Let's say you are a bank and you have still not started using maybe robotics or IoT services. And you do not want your developers to start creating resources using IoT and robotic services yet. Maybe you will use it in future. So you have a deny policy at the organization root level, which denies use of RoboMaker and IoT service. Now let's say you apply another SCP down the chain, which is at a OU level. And let's say you do not want your developers to run instances, EC2 instances, as and when they want. So we want to see what is the effective policy at account A, because we have two policies applied over here, one at the root level and one at the OU level. And both are deny policies, by the way. So the account A inherits all the three actions. So you won't be able to use RoboMaker IoT service in account A, and you won't be able to perform EC2 run instances in account A. And same goes for account B, because it is part of the same OU and organization. So the deny is inherited based on value applied. The second technique is combining your policies together. So the maximum number of policies, SCPs, that you can apply at each level in your organization is 5. So you can have 5 policies at the root level, at the OU level, or at the account level. However, the good news is you can apply it at different levels, but you can only apply 5 policies. So you have to combine policies together. Now, you may or may not know this, but when you start using SCPs, you start off with a full access policy. It doesn't essentially mean that every entity has full access. It just means that you do not have a guardrail at SCP level, and you are relying on the IAM permissions for the access. So the first policy is something that we implement when you enable SCPs in your organization. The second policy is something that, let's say, you want to implement. Maybe you are using, you have S3 buckets in production, and you do not want anybody to have any access to delete your S3 buckets. Security Hub is a security service offered by AWS. You can look at different findings and look at the security posture for your AWS accounts in that. So let's say you do not want anyone to even disable Security Hub service. You can combine these two policies together. However, you always have to make sure that your intent remains same. So when you're combining the policy together, make sure that your intent remains the same. Whatever you wanted to deny is still a deny at the end of combining policies together. So if the effect and resource is same, you can combine them together, but make sure that your intent remains the same. I really want to focus on that. The third technique is compacting your policy. So we talked about the number of policies that you can apply at each level. However, the maximum size of an SCP could be 5,120 bytes. So if you're using AWS Management Console, it automatically removes the white spaces when you save the policy. However, if you are using a code pipeline, CI/CD pipeline, to implement SCPs in your organization, then you will need some lines of code in there to remove white spaces before you deploy SCP. And this is kind of a last resort. So SIDs are statement IDs, which is a completely optional field. You can use them to put in a reference for what a particular policy does. So you can say following policy denies deletion of S3 buckets. And if you are running out of space, then you can just remove the SID or shorten it. You can even have it in your code, but just strip it down before deploying the SCP in your organization. Okay. So as I said, I want everyone walking out of this session to have at least some SCPs in mind to get started with. The first one is prevent leaving the organization. And this is kind of an important one, right? When you apply SCPs, you want all the accounts in your organization to be still a part of your organization. Only then SCP is applicable. So have a policy that denies any account to leave your organization. Also, there are a lot of good things that organizations has to offer, right? You can make use of consolidated billing, discounted price. You can also centrally secure and audit your environment across different accounts. And you can implement central controls using SCPs. I do have a link to a resource that lists all the 5 top recommendations for you, which I'll share it out after this session. And it is also on our last slide. So you will have it for your reference. The second one is only allow usage of approved AWS regions. So now AWS gives you a choice to choose from multiple AWS regions based on where you want to create your resources globally. However, if you are a company that only operates, let's say, in few regions, you have compliance needs. You do not want your developers to create resources in the regions that you do not approve of. So have a policy that denies creation of resources in the regions that you do not approve of. You can make use of the not action over here to specify the global services, and you can make use of string not equals with requested region to provide the regions that you actually approve of. The third one is prevent usage of the root user. Now, root user is guards mode, has administrator access. You do not want to use root user for your day-to-day activities. And you do not want to give access to your developers or any other teams in your organization to use the root user, right? You use roles for it. You can scope down, you can have least privileges on that particular role, and you can use it for day-to-day use, but not the root user. And there are actually only few small number of tasks which requires the usage of root user. So have a policy that denies usage of root user. You can even use a star in the principal ARN over there if you have multiple AWS accounts and if you do not want to specify each account over there. So you can have a star over there that will take care of hundreds of AWS accounts in your organization and would deny the usage of root user in those accounts. I just wanted to highlight one more thing over here, although I have linked it over there. But if you're looking for the tasks that could only be performed by root user, I have a link over there. The fourth policy is prevent disabling of security services in your organization. So there are multiple AWS security services that help you look at the API calls made against your AWS accounts. And you can use them to actually look at the security posture of your AWS accounts. And there are actually multiple, but I have only included 3 over here based on your use case. So AWS CloudTrail is where you can monitor the API calls made against your AWS accounts. Config is where you can look at the configuration on your resources and compare them with your desired configuration. And Security Hub is one-stop solution to look at the findings coming in from different accounts and against like best practices. And so if you're using any of these services or any of the security services to monitor your AWS accounts, have a SCP that denies disablement of these services because you would need them. And the last one is my favorite, prevent your sensitive S3 buckets. So let's say you have an S3 bucket that has objects that are actually images that are shown up on your website. These are your production S3 buckets, and even if you have like sensitive data in there, you do not want to give anyone access in your organization to delete your S3 buckets, to even change the public access settings on those S3 buckets, or even delete those images or objects in your S3 bucket. So protect your S3 buckets. So that was the last policy that I wanted to talk about. Now that we know what SCPs are all about in theory, I would like to call upon stage Itai from Morgan Stanley to talk to us about how Morgan Stanley's AWS organization evaluation looked like. Thank you.
Thank you, Swara. Zulfi and myself and my colleague Zulfi and I are both from Morgan Stanley Cloud Engineering team. And Morgan Stanley is a global financial organization. And so we care deeply about security and compliance and protecting our customers' data, which is why we're so entrenched in SCPs. We're going to talk a little bit about our journey throughout time by using AWS Organizations and SCPs. Okay, so this is how we started, right? AWS Organizations, OUs, makes sense, right? We have an org chart. Let's mirror it. This is a similar practice that we've done throughout time with LDAPs. You have departments, you have BUs, you create the same thing. So you have enterprise, HR, security, just create the same thing. Makes sense, right? This department will not use these services, that department will use that services. Made sense. However, that's a common thing that happens in large organizations, right? Department A is now rebranded as A++. Department B merged with Department C, and Department D doesn't exist anymore because something happened. So definitely we went down the wrong path. So learn from our lesson here. Don't do what we did. Don't attach or build your organization based on your actual organization, right? 'Cause that changes. Don't align it to something that changes with time. Instead of that, what you should do is align it to technical aspects, right? Group your workloads based on their exposure to the internet or their security policy, if it's different. Or group them based on, I don't know what, the region they operate in, or based on the set of services that serve for the same workloads. Because it makes sense. The SCPs are around technically protecting your organization. Okay, another lesson that we learned here, right? We originally, as I said, right, as we based this on our org chart, it made sense for us that different business units, different OUs would have different controls, so different policies. So OU A, BU A has this denied that they won't use databases. Let's deny that. OU B, well, they don't need Lambda functions. Let's deny that. Or OU C, we don't trust them to do IaaS, so let's deny that either, right? And then there's sub-departments, under HR, accounting, they need billing, but they don't need this. And I think you can understand what happened here. It got a little bit complicated. And that led to this, right? We are the central cloud engineering team in Morgan Stanley, and our customers would reach out to us. I got this access denied. I can't do this. I should be able to do this. Very common. However, then we started figuring things out. Wait. You have the permission, but where is it in the SCPs? Luckily, AWS has like some good hints there. If something is denied by an SCP, at least in the error message, it says it's explicitly denied. So you know it's from SCP. But where and which SCP? Is it in the account? Is it from the OU? Maybe it's from the root. And you end up sifting through all these policies to figure things out. And it gets complicated, right? So don't follow that practice. So the lessons that we learned here are multiple lessons around how we build our organizations and basically set our policies up. First of all, we recommend that all the SCPs are going to be maintained in one place, right? One layer. The root, the management account should be that layer. That way you don't have to look. You know where it is. It makes sense, right? And I'm sure somebody's going to say, wait, but you just said a minute ago that different OUs behave differently. We'll get to it in a second. The second aspect I want to talk about is immutability. When I say immutability, I mean actually more than one thing. First of all, as I said, the OUs define the security stance. The account should not, the SCPs should not change. And I'll retro to a few seconds ago when Swara presented that the root account, some activities you should use the root account for, even though you should block it out. But attaching and detaching policies is not a good policy, right? We could be numb to this event. Maybe someone, a disgruntled employee or whatever, somebody decided to detach a policy. So don't do that, right? It will make us numb to these events. If you want a security policy to change for you to do something, take the account, move it elsewhere, right? There should be like a staging area where root is allowed. Move it there, do the work there, move it back when you're done, right? That way you're not attaching and detaching policies. If you have a yard, like a yard with a fence, you're not gonna remove and re-add the fence. It just doesn't make sense. So the second aspect of immutability I want to talk about is immutability of code, right? Swara presented a couple of minutes ago that you can go and edit the SCPs in the console, and it links it for you and removes spaces. All great things. Never do it, right? SCPs should not be edited by hand. That's also an event that we should, if we can, block it, right? You'll not be numb to that event if it happens. SCPs should be maintained as code, as artifacts, so you can know what is actually being deployed. There's enough infrastructure as tools out there to actually help us to build a pipeline of deployment, so you know what you have is actually what is deployed out there. And that leads me to the third aspect. SCPs, well, I wouldn't say it's the last line of defense, but it's definitely one of the more important lines of defense that we have, right? You cannot guard it. So if your SCPs are in one place, as I said, and they're maintained as code, as I said, the third option is, it makes perfect sense. Monitor for it, right? There's a bunch of tools out there in the expo that will go and monitor anything for you. But you could go cheap here, even like a cron job with a script that goes and pulls the SCP to see that it's still there, to see that the contents is equal to the contents that you have in your code repo. So it's definitely important. Okay. A third thing that happened to us here, and Swara was also focusing on it. So SCPs are limited to 5K, right? Which is a problem, right? And what happened to us is, because we started putting everything in SCPs, policies grew, and then policy 1 turns to policy 2, even though it's the same purpose, and then you're like in a place when you have more than 5. So it's definitely a problem. Luckily for us, not everything needs to be in SCP. That's sort of the lesson that we learned. Even though you can put things in SCP, like the S3 TLS example that was presented a little bit earlier, you can put it in SCP. You can also put it in IAM. You could also put in a boundary policy. Also, nowadays, I hope we all use infrastructure as code to deploy resources. You can bake it into your infrastructure as code templates. Whether you use Terraform modules or CloudFormation stacks, you could easily bake this control in there. Also, putting in an SCP will not always defend the problem, right? As we saw a minute ago, it won't always protect us. So keep SCPs as coarse-grained as possible, right? Very high-level controls. Less is more, right? We should do like a economy of mechanisms here. Okay, so after all this journey and all the evolution, this is what we ended up with. Our organization is 4 layers. On the top, the first layer, you have the management account, the root, where we put the deny policies. The red is deny in the diagram behind me. One place, one single layer, makes perfect sense. On the bottom, 1 layer down, we have the OUs. The OUs are based on technical controls. We split IaaS and non-IaaS due to, well, you guys know that most of the security issues come from networking, from EC2s. So if you have an attack surface, you can just limit it. Why not? Also, around exposure to internet, because why would you want to, allow opening all the workloads to the internet? Only do what needs to be done. One level under that, we have our sub-OUs, and those are dedicated to regions because you would want to group the workloads based on the regions you're running in to limit even things further. So if you have a use case that's allowed to operate in Europe and you have a use case that's allowed to operate in the States, they should not be, you shouldn't allow all of the regions. And at the bottom, we have the actual accounts, the actual workloads in the sub-OUs. And as you can see beside them, there's the green icon for security policies. And those are our allow lists. Basically, we allow the specific services that workload requires. So denies at the top, allows at the bottom. Okay, let's focus in a little bit on the management account and the deny policies that we're talking about. These are some of the deny policies that we have on the root. Firstly, I'll start with the first one. Shwar presented this earlier. If you don't have it, make it, right? Limit the regions that you're operating in. It's very important for financial industries because of different compliance reasons, but most industries have this, whether it's GDPR that's in Europe or HIPAA, every region has its thing, right? You want to know where your data is. You want to exclude all of the regions that you're not using. The second one I want to talk about is deny exfiltration. And for here, I'll tip my hat to AWS. AWS this year released a great feature to allow us to prevent exfiltration of data to past services. I'm talking about the IAM key resource org ID. If you don't know it, read about it. We'll focus in on this a few slides down. Zulfi will. The third one that I want to talk about is thou shall not. That's like our generic SCP, generic purpose of things that just you should not do. And it doesn't usually focus on a specific service. A good example here is like MFA. You must use MFA or deny root or whatnot. So all the things that are a must, right? Those are all the generics to the top. And on the fourth one is the magical one that solved the problem I presented earlier. If you have different OUs, and you don't put policies on them, how can you have them act differently and have different security stance? And this SCP is the solution, right? It uses org resource path, which is another IAM key that is very powerful, that allows us to refer to the children of that OU and put different security behavior on them. We'll present this deeper in a couple of minutes. Okay, so I talked about this pipeline that we have and about managing all your SCPs as code. This is what our pipeline looks like. It's actually more than one pipeline. We focus on segregation of duties here. the team that deploys the SCP or even creates the SCP should not be the team that uses it, right? It should not be the same people, because you might, do things the wrong way. More eyes is always better. So we have one pipeline for our SecOps team. They go, obviously, in concert with the engineering team, create the SCP. It goes through rigorous approvals. Everybody looks, everybody chimes in, and it gets deployed with a pipeline. You know the version, you know everything, and it gets deployed into AWS Organizations. And on the bottom, you can see our DevOps pipeline, which is where we actually deploy our applications, right? It's not the same pipeline, even though it is also infrastructure as code-based. Create your code, the Terraform, CloudFormation, whatever you use, go through a review, it gets deployed. Now, based on some attributes, the right allow policies, the service allow policies are chosen, and the placement of which OU the workloads goes into is also chosen there. So you only refer to what was deployed. The deployment of SCPs is not part of the deployment of the application. Okay, now to go in a little bit deeper to some of the use cases of how we use SCPs and how SCPs actually protect us. If you zoom in, I'll call in Zulfi, my colleague, on the stage. Thank you. Okay.
Thanks, Itai. Hi, I'm Zulfi. I'm part of Cloud Platform Engineering at Morgan Stanley, and I'm going to present expanded use cases that we employ in our environment, and I believe are going to be beneficial to the audience looking to strengthen their security controls using what we call SCP guardrails. So the intent is to share tangible practices for the audience so you can start strengthening your SCP guardrails like we did ours. So a recap of what Itai earlier presented, a quick recap. We got allow policies at the account level and deny policies at the root level. So it's the deny policies that we call guardrail policies. We call them guardrails because they are our last line of defense, or I should say one of the last lines of defense. When everything else fails due to the security compromise of an account or an operational accident in an account, guardrails prevent the most risky actions. And the fact that the guardrails exist in the organization managed account, they are out of the failure blast radius. And if we make guardrails immutable, like we'll see in one of the coming slides, we can have assurance that they will be always there to protect us. So let's get started. Our first use case is about governance and housekeeping. We manage all phases of our account lifecycle through code, and that includes account creation and account closure. Humans in our organization do not have ability to create account or close account. Those permissions are only available to the automation principles. In addition, our source of truth for SCP content is code, like what Itai said. If an auditor asked us to provide a current version of an SCP policy statement, we'll point them to code. And last but not the least, our organization membership is by birth, not by invitation. And this is to ensure all accounts belonging to our org were created using a consistent security baseline. And members in our organization cannot leave organization and cannot be removed from organization. So if you lately checked out AWS Organizations console in the management account, you will see a permission or an option to remove account from organization and another option to close account. So each of those two options is obviously visible in the management account console and can be completed in 2 easy clicks. But there are security and operational consequences. So we block permission to remove account from organization altogether. And the fact that the permission exists in the management account, which is not obviously controlled by SCP, so we have to use a different mechanism. So we block that permission through permission boundary. What we also block in permission boundary is the ability to close account for human principles, so the account can only be closed through code. So obviously, closing account through code gives us checks and balances as well as deliberations, not otherwise available through console. So the bottom line is account has to be managed end-to-end through console. Let's take a look on our next use case, which is about least privilege principle. So we do not attach AWS full access to any account. Actually, it's full AWS access. I'm used to calling AWS full access until I was reminded it's full AWS access. It's that built-in SCP that has wildcard permission to every service, and it is by default attached to every account upon creation. And we have a post-account creation that removes that SCP from every account, and there are no exceptions. I mean, not removing that SCP will make our SCP controls ineffective. So we're cognizant of that, and we rigorously monitor it through our assurance tools. As a matter of fact, every new service onboarded in our SCPs goes through a rigorous security review. Now, there is an extension of this use case where we recognize that there is a set of baseline services that we will always need regardless of the type of account in our organization. And those are the services we will require to, for example, support automation or let's say enable security, basic security and operational controls. So we include all those services in a baseline SCP and attach that baseline SCP to every account in our organization regardless of the type of account. Of course, an account can have additional SCPs attached to enable services specific to support its own use cases. But those would be deltas from the baseline SCP. So far we did a use case on governance and housekeeping, and a use case on least privilege, now a use case on data exfiltration. And I hinted on that earlier. So earlier this year, AWS introduced a new IAM condition key called resource org ID. So it substantially helped us to strengthen our data exfiltration controls so we can deny data uploads to data sources not belonging to our AWS organization. And now this is in the context of data, in the context of uploads happening from within AWS instances or EC2 instances. One specific implementation of this use case would be to deny S3 puts to the buckets not belonging to our organization, which is a very compelling use case. So let's take a look on the policy statement. We got deny S3 put star, resource star, and then we got the condition resource org ID, and that's where we will include the ID of our AWS organization. And of course, based on the use case, we can have multiple org IDs belonging to our, let's say, our trusted third-party partners and vendors. And now our use case, flagship use case on immutability that Itai hinted earlier. So 3 years ago, AWS introduced an IAM condition key called principal org paths. Just want to make sure I'm pronouncing it correct. Yes, it's principal org paths. So it was a game changer. It allowed us to decide what an account can do and what an account cannot do based on OU memberships. So if an account, for example, if an account is a member of internet-facing OU, the account will be allowed to attach internet gateway. If the account is not a member of internet-facing OU, the account will not be allowed to attach internet gateway. And all of that is being decided from a guardrail SCP attached to the root, not the OU, attached to the root. So this gives us a powerful capability of constructing policies once and attaching forever. And how does that happen? Well, our org design eliminates the need to detach a guardrail SCP or create an exception to a guardrail SCP. This is because our SCP rules have an inherent flexibility to allow exclusions based on OU memberships. So with that flexibility, is there a scenario where we would ever need to detach our guardrail SCP from root? Well, over the last 3 years, we have not had any. So that means we can permanently disable permission to detach guardrail SCP from root. And when we do that, we make it immutable, and we get an instant monitoring advantage. Monitoring a few guardrail SCPs attached to a single target that are permanently attached will give us clear outcomes. There will be no false positives. Versus monitoring a whole lot of SCPs attached to a whole lot of target OUs, and some attached, some detached, there will be lots of false positives. Like what Itai said earlier, this is all about security design principle of economy of mechanism. And let's go to our last use case. And that is about reducing attack surface. So when dealing with hundreds of accounts like we do, we always need a place of quarantine where we can disable all control plane actions to an account. And examples would be, for example, an account waiting to be decommissioned, or an account isolated for investigation of a security incident, or an account already decommissioned and waiting to be closed in that, waiting to be deleted, I should say, in that 90-day period. So when we move an account to a lock OU, the guardrail SCP will deny all control plane actions to the account, so the account will be practically in a paralyzed state. So let's take a look on the policy statement. We got deny star, resource star, principal arc paths, and that's where we got the path of our lock OU, which is the second line. The line at the top is the path of the root, and that is to disincentivize users from creating accounts directly under root, because if they do, the account will be created in a paralyzed state. Notice the trailing slash in the at the end of the arc path. That there's no asterisk at the end of the trailing slash, which means this condition only applies to the direct members of root, not the sub-OU members, and that's how this condition plays out. So that concludes our 5 use cases. I hope they provide tangible, like actionable takeaways for the audience. I would now conclude with a summary slide, which has a summary of best practices that we as a firm follow when it comes to SCPs. And this is for self-read, and I will leave it on my screen while I turn it over to Swara. Thank you for listening in.
Thank you. Okay, so that's all we had for you today. These are the resources that I was talking about earlier. The first one is a branding blog that came out this year. It talks about the tools and techniques that we discussed today. The second link is the one that goes to the example policies. So it comprises of the 5 policies that we talked about today. And it also has some other ones that you might want to use according to your use case. And the last one is a link to the AWS Organizations page, which has a list of services that you should include in the not action parameter when you are putting a policy that only allows usage of certain regions, because some services are global services. So the last link goes there. We will have a PDF of these slides sent out later, so you can have those links. And finally, thank you for coming in. These are our email IDs. So if you would like to continue this discussion, if you would like to let us know how you use SCPs today, feel free to reach out to us. And please fill out the survey. I read each and every feedback that comes in. So let us know how you felt about our session. If there's something that needs to be added, if you would like to see more of the SCP content, we would love to do that. So please let us know throughout the surveys. Thank you.